Welcome to Physics with Mr. Brazil. We're going to determine the inertia of a pulley, a two-person frictionless crank pulley having a diameter of 0.5 meters, has a massless cord spooled up, with a block having a 0.5 kilogram mass attached on a frictionless 30-degree ramp. The crank pulley is released when the block is at the top. The acceleration of the block pulley system is 1.5 meters per second squared. What is the inertia of the crank pulley? The crank pulley is right here. It's off to the left. Let me get a pen for you. It's right over here. And it's just two people crank it and bring it up. So the tension is on the cord here. And we should make a free body diagram. So off to the left here, I will make a small free body diagram. We have Fn, Fg, and we have the tension. This whole system is accelerating to the left, to the right, a positive ma. So the tension, or the sum of the forces for the tension, is, I'm going to call it the F direction because I like to make the ramp an XY axis. So we have Fgx, if you look over here to the left, that's a component vector that's parallel. Other teachers like to use Fg parallel. This is just mg sine theta. So what we're going to have is we're going to have a negative tension plus Fg, and I call it x, equal to a positive mass for the block times the acceleration in a positive direction. So if we solve for t equals, t is going to go over, so it'll be m, the mass of the block, g, minus the mass of the block and its acceleration. Okay. We need that acceleration. That acceleration accounts for the inertia of the block and its angular acceleration. So now we can take the torque, and we take the sum of torques. Now the pulley is going to be spinning, and if you look here at the top by the pulley, I'm going to make an arrow with an arc, and I like to use the right hand rule, so this is going to be a minus direction. So it's going to be going minus. So the tension itself, the torque for that, is a negative tension, or tension due to the torque due to the tension. It's going to be equal to I alpha. Alpha will also be rotating in a negative direction, okay, because due to me using the right hand rule. So I alpha. So the torque due to tension is going to be the radius. I'm going to keep the minus. I'll keep the minus over on that side. Okay, equals I, and the minus will disappear, A over R, because A equals alpha R. These are equations I want my students to remember. Now that I know that, I'm going to get rid of the minuses, and I'm going to put the tension. I'm going to put in what the tension is equal to. So that's going to be mg minus mb a times r squared equals, sorry about that, equals IA. Well, now we can solve for the inertia. The inertia is the mass of the block minus the mass of the block minus the block mg. Restate. It'll be the mass of the block times g minus the mass of its acceleration times r squared over a. So let's plug in some numbers and see what we're going to get. I could probably, I'm going to factor out the mass also. So the mass is 0.50 kilograms times 9.80 meters per second squared minus the 1.5 meters per second squared. And since R is going to be half of the 50 meters, so it'll be 0.25 meters squared, and our acceleration is 1.5 meters per second squared. See what we get. I'm going to put this in a calculator real quick. 0.5 times 9.8 minus 1.5 times 0.25 squared over 1.5 equals 0.17 kilograms meters squared. So that's the inertia. Now here's the thing. I took the force to determine the tension. That's on the cord. Then I went to another of my toolkits, the torque, because I know there's angular acceleration and I can convert that to regular acceleration, and it's just a matter of algebra to determine the actual answer. Okay, have a great time studying, and physics is everything, as Dr. Lincoln would say. Bye.